So, good evening. So, this is a mode plot problem. So, the question here is sketch the Bode plot and determine the system gain K for gain crossover frequency WGC is equal to 5 RD per second. So, the given equation, the given gain is G of S equal to Ks square divided by 1 plus 0.2s and 1 plus into 1 plus 0.02s. The first step we are going to assume that this k value is 1. Then we are going to replace the s equal to j omega. So wherever we are getting s, we have to replace that value into j omega. So here is a value g of j omega equal to j omega square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. In the second step, we have to calculate the corner frequency of the given gain. So the for corner frequency, you have to make a table column, headings, term corner frequency radian per second, slope in dB, and change in slope. So the first value, you can see here the first value j omega square, the second value 1 plus 0.2 j omega and 1 plus 0.02 j omega. So first value we are placing the values here j w the whole square, and the second value 1 by 1 plus 0.2 j omega, and third value 1 plus 1 divided by 1 plus 0.02 j omega. The first value, you can see there is no real part in this, so we are placing nil in the corner frequency, and it has 2 j omegas. Since if there is only one j omega or only one s, we can replace the slope in we'll replace the slope as minus 20 degrees. Since it is a square, it has 2 j omegas, so we're replacing 40, and you're replacing the value as plus 40. And since it is the starting slope number, there will be no change in slope, so we are replacing it as nothing. And the second value 1 divided by 1 plus 0.2 j omega, that is equal to WC1, actually it's WC1, so WC1 equal to 1 by 0.1, that is the real part divided by the imaginary part, which comes to 5. And the slope in dB will replacing this as minus 20. And the change in the slope, we have to add the previous value with the current value, so the plus 40 and minus 20, that is equal to 20. And coming to the third value, the 1 divided by 1 plus 0.02 j omega, so WC2 is equal to 1.0.02, that is equal to 50, and the slope in dB is minus 20, so the plus 20 and the plus 2 previous value and the current value will be added, so that is equal to 0. Since we have to plot the magnitude in the graph, we have to take additional 2 more points in in the values lesser and the higher values. So you can see here we have a value of WC1 as 5, and we have a value of WC2 as 50. So we have to take a lesser value than 5 and the higher value above 50. So we are replacing the two values, that is omega L is equal to 0.5, which is the lesser value radian per second. Similarly, the higher value omega h is equal to 100. We are taking two values and coming into to the formula. At W is equal to, at omega is equal to WL. which is here a is equal to 20 log j omega square, where w equal to wl. We have to replace the omega value as 0.5, so we are replacing the value here, and we are getting 20 log 0.5 the whole square, and on converting we will get a is equal to minus 12.05. So the approximate value is minus 12 dB, and after the WC1 we have to go for WC1 value, and so a is equal to 20 log j omega square, that is equal to w is equal to WC1. We have to replace the omega value in WC1 value. WC1 value we know that is 5, so 20 log 5 square will get the answer on 27.95. So the approximate value is 28 dB, and after the WC1 we are going to find the value for WC2. The so WC2 we know the value, that is WC2 is 50, which we have taken, yeah, which is already find in the magnitude table column. So the formula for this is a is equal to slope from WC1 to WC2 into log WC2 divided by WC1 at at W is equal to WC1. This is the previous value. So first the slope from WC1 to WC2, you can see here the slope from WC1 to WC2. So we are replacing the value as 20 log, so the WC1 value to WC1 value is 50 divided by 5. 50 divided by 5, and the value at W is equal to WC1. This is the previous value we have find out, that is W is equal to WC1. So we are replacing that value here. So we are getting A is equal to W8, A is equal to 48 dB. So similarly, in the next value, at W is equal to WH is equal to 100. So the slope from WC2 to WH. So WC2 to WH, you can see here, WC2 to WH, that is 20. That is 20, and we are replacing the 0 value here into log WH. We have assumed that is 100, and WC2 value we already know that is 50, and at the W is equal to WC2, that is the previous value we have find out previously. So we have to replace that value, and we'll get the A is equal to 48 dB, and we have to form the tabular column, and one is omega and the other one is gain in dB. So for 0.1 we'll get minus 12, and for 5 WC1 we'll get 28, and 50 it's 48, and 100 again it's 48. So this is the points for the magnitude plot, and then we are moving into the phase plot. So the formula for the phase plot is theta is equal to tan inverse omega square divided by 0, and minus tan inverse 0.2 omega divided by 0, and minus tan inverse 0.02 omega divided by 1. So since there is 2 omegas, if there is only one omega, we will take it as 90 degree. Since there is square, so we are taking this 180 degree, and tan inverse 0.0 omega w, and minus tan inverse 0.0 w you have to replace this value, this omega values with our value, and we have to additionally add a value between these two values. For example, 0.5 and WC1 we know. So in between we have to take one point, which may be 2 or 1. Here I have taken 1. And for between WC1 and WC2, I have taken this as 10, and for 50 and WH I have taken 70. So these are the values. So these are the values while replacing the omega value as 0.5, and we'll get 174, and for 2 it's 156, and 138 for 5, and 10 for 105, 150 for 50, and 70 for 40, and 100 for 80. These are the values for the magnitude plot, and we are going to place all the values in the graph. Thank you.